Hi everyone, my name is Nicole Granucci, and what I'm going to do is do a video introduction to physics and measurement. I call this lecture 0, particularly because this is kind of the preview towards physics, but mostly a mathematics review. Some of the stuff that we're going to do here, you probably have seen before, but maybe it's been a while since you used it or you're not familiar with it. So this is kind of like a primer into physics, and I wanted to show you a couple of things that I think will be helpful for you after teaching this several times. I'm going to talk a little bit about scientific notation, metric units, some standard conversions. We're going to be doing a lot of conversions in the course. It's not like chemistry where it's like a whole section devoted to just conversions, but we will go from meters to or centimeters to meters. We'll go from grams to kilograms. So having some notion and understanding of those conversions is really helpful. We'll do a little bit in graphing, a little bit in right triangles, and actually I should add another piece is a little bit on the calculator. And I know all of you are probably like, why do I need information on the calculator? Surprisingly, the number one thing that people get wrong in physics is not so much that they don't know the calculation, is just how to use their calculator correctly. Now I'm going to show you some tips and tricks to using your physics calculator. Now you don't need a TI. This one I splurged because after 20 years I finally got a new calculator and got the updated TI-84. But you don't need that. In fact, you just need actually a scientific calculator for this course. It's nice to have a TI-84 because of the features, but we're not graphing in this class. What is nice about the TI-84 is you can store values and you can enter big values. So that's something I'll talk about at the end of the video. So here we go. First thing I want to talk about is using scientific notation. Again, this is totally a review, and if I botch this up, obviously do what you know and what works best for you. Just know that my method isn't the method to, I don't think I'll botch this up, but you know what I mean. If you already understand this, you can literally skip this part. But scientific notation, of course, is useful for writing values that are really large or very small in a more complex, more compact way. Now, I'll tell you this, that your Mastering Physics account loves significant figures in scientific notation. With that said, being able to read and convert from scientific notation back out or vice versa is important. So definitely get used to going back and forth into those notions. Now, I won't do significant figures in my course, but your online homework does do significant figures. So, for instance, if you have something like this guy's thought bubble where you have 3 significant figures, then you might need to do it in 3 significant figures as your answer. That's not the end-all be-all way to do things. The point is, if you find that when you're calculating your value and it's not accepting your answer, one way to try something out is to simplify it. So instead of 3.45, try 3.4. Maybe it only needed 2 significant figures because it does depend on what other numbers are there and all that fun stuff. Or maybe you just need to enter it as 3. That's another possibility. So just heads up on that. So, scientific notation, basically what you're going to do is you're going to find that decimal place and you're going to move it, right? If it's a large number, you move it to the left. So, and then I count how many times I do that. So, 1, 2, 3, 4, 5, right? So the decimal place now goes in between the 5 and the 6. And there you go. And then since I moved it over 5 times to the left, I raise it to the power 10 to the 5. Now, yes, there's a bunch of digits here, but it's now lost. We're simplifying it and writing it to scientific notation. Depending on the significant figures, how many you keep, but in my class, I'll just tell you 3 is fine. In other words, these 3 digits for scientific notation is perfectly acceptable. That's not true for your Mastering Physics. It really depends on how many, but the rule of thumb is usually about 3 significant figures, if not 2. Small number, you go to the right, so find the decimal place and go 1, 2, 3, 4, 5, 6, 7, 8. Now, since I went to the right instead of left, I have to add that negative sign. So notice that this means left even though it's positive. It doesn't have the positive sign. but it went left and this went right. So it's showing you how to write these in scientific notation. And there is the same thing over again for you. I love visuals. I'm a visual person. So you'll see extra visuals just because I think you'll learn by seeing diagrams and pictures. Yes, units are very important, so just use them. I know that it's so easy just to write down numbers and feel like a computational course or math course where you just write down your answer as a number, but it's different. It's physics, it's not math. So the numbers have physical meanings, so it's very important that you add your units. In fact, regardless of what it is, I will take off a penalty for units because we're not a math course. So when it comes to, one example is $5 is different than 5 cents, $500 is different than $5. So those units absolutely matter. So just be aware and to use them at all times. It is super tedious. I know because I do it all the time, especially when you have lengthy questions. But it's important that these are not numbers. They're quantities that have specific meanings. So just be, very diligent about your units. These are the standard units. We follow a metric system. So that means for anything with mass, it has to be in kilograms. So if you have to convert, you have to go from grams to kilograms, which happens on your Mastering Physics homework questions. You have to learn how to do the conversion, so more on that very soon. Meters, same thing. We're going to give you measurements in all sorts of ways, centimeters, meters, kilometers. You can have some as small as angstroms, so, but it has to go back to that meter. And the main reason why is because all of our constants and everything else that we measure in physics is in the metric system. So we can measure in other systems, but we have to calculate and convert in metric. We're not going to deal with volume at all, but if you were curious as the leader, force we will deal with quite a bit. It will be in newtons. Temperature will be in Celsius, surprisingly enough. And actually, we're not going to do temperature, so I'll let you know that right off the bat, that we won't do it. But actually, in physics, we actually stick to the Kelvin system instead of the, so degrees Celsius is actually a calibration of water, and Kelvin is calibration of energy, so it's a more meaningful measurement, at least in physics. And then, of course, the time is in seconds. So usually time is pretty good, but when you have things like the orbit of Jupiter, or the length of the time in hold on, I could do this. The time for a year in seconds, that gets kind of big. So, and then there's other things that are really small, like how fast light travels 1 meter. That's going to be incredibly small. So the second is actually a pretty appropriate measurement, despite its small appearance like that. So we'll measure things in seconds. And of course, there's more units we'll use, and I'll introduce them as they come. And they're going to be derived from these basic units right here. So in other words, when I do energy, even though I'm going to define the energy as a joule, the basic unit is a kilogram meter squared over second squared. So every unit that I make in this course is going to be derived from this. So these are called base units, and the other ones are called derived units. You don't need to know the difference, but you will recognize them is the most important part as we go through this course. There you go. SI means Standard International, so everybody in the scientific world uses these measurements. It's very convenient if we all use the same thing. Here you go. Fun facts about where these things come from. So the length of the meter actually is, it used to be the distance from the equator to the North Pole. Fun fact, right? But actually, they've now calibrated it to a highly more accurate measurement, which is how far light can travel in a vacuum. The kilogram is a mass sitting some country in Europe, I don't remember where we just all defined it as the kilogram, and that's what we use for the mass. And then the second, the duration of a second is based on the vibration of a cesium atom. Fun fact with that. So this is where those measurements come from. You're not going to be tested on this, but hey, maybe you have a trivia session or you go on Jeopardy, and there you go. Metric prefixes, once again, I think most of you are familiar with this, but millimeter versus centimeter, meter, and kilometer. So obviously we're getting bigger in these measurements. The base unit is the meter, but the prefix gives us some information about how big or how many more meters is involved, so very, very helpful. You will definitely convert from meters to centimeters, or actually from centimeters to meters, nanocoulombs to coulombs. So these are all things that we're going to work with. So being familiar with these will be very important. I'll introduce these as we go through because I assume that, unless you're using them every day, you don't really memorize them. So don't worry about memorizing this. You'll always have access to this. More importantly, you do need to know how to use it. That's important. So let's do a couple quick examples. So there's absolutely shortcuts to all of these things. I hope you know that. And if you know how to use your shortcuts, then absolutely use them. I'm not a proponent of my way is the only way. What I will do is show you the standard way of doing it, and then I'll give you the shortcut, okay? Because it's good to know both. Oops. So we're going to go from grams to kilograms. So we're going from here to here, right? So the way I do this is I start off with what I have to work with. So I start off with the grams. In fact, I don't know why I wrote that out. Here we go. Like that. So the other thing you have to find out is how many grams are in a kilogram. So if you don't memorize these things, you can look them up. Now, I'll say this, when it comes to, working online on your homework, it's very easy just to go to Google Converter and convert it, which is fine. But I'll tell you, don't do that unless you really absolutely understand how to do this, because you may have to do this on a test. So if you don't know how to do this on the fly, then don't do it on Google Converter or whatever converter, because you'll have to learn how to do this. So remember that these are the same measurements. So if I were to put this in a glass, 1,000 grams, is the same measurement as 1 kilogram, right? This is essentially what this is saying up here. These are the same exact amount. So, in other words, if I make this into a fraction, it's the same as saying 1 divided by 1. So, fun little fact. I'm basically going to do that without changing my number here, which is very important that I don't do, right? I don't want to change the number, I just want to change the units. But to write the fraction, the way you want to do it is you want to pick the number. So first of all, notice we're in grams. And I want to pick the number that will cancel out grams. So it has to go on the bottom. We want these to cancel so that we're left over with our units that we're desiring, which is the kilogram. So in fact, anytime I do this, well, I do a lot of this in my head now, but if I'm doing something more complicated, what I do is I do this first and put this down, and then I go to my conversion and say, where is the number attached? The grams is attached to the 1,000, so the grams goes here, the 1,000, and then the 1 is attached here. Because I want those units to cancel, grams goes away, and then I go ahead and calculate 24 times 1 divided by 1,000. So when I get that, I get 0.024 kilograms. And that's the conversion. Now, the shortcut, I recommend using only when you understand this, okay? So don't, because the problem with the shortcut is you may shortcut the wrong application, and that's the problem, as sometimes people just blindly use the shortcut and maybe use it wrong. But the shortcut is to go from grams to kilograms, you divide by 1,000. So if you know that, great. And notice that's exactly what I did here. Another conversion you can make is from meters to nanometers. That's fun. So remember, we're going from nanometers to meters. So first you got to look up a nanometer, or whatever the symbol is. Maybe you don't know this. And for a nanometer, it's 1 times 10 to the negative 9th meters. That's the conversion. So we start off with the 450 nanometers times in every 1 nanometer. There is 1 times 10 to negative 9th meters. So I did that faster, but notice that I took the nanometers and made sure they were on the bottom. The 1 is attached to the nanometers. and that allows me to cancel these out. It leaves me with what I want, which was meters. I usually cross things out and circle as I go along, especially when it's more complicated. So how many meters? So basically I'm going to do 450 times 1 to the negative 9 divided by 1, which nobody will do. When you do this out, you get 4.5 times 10 to the negative 7th meters, like that. So if you don't memorize these things, you definitely have to look them up. This is something I wouldn't memorize because it's not always 450. I could have a 4 here. I mean, things change. So it's actually better to walk through the conversions like that. So those are some metric conversions that you might do in this course. And look at that. They're nicely written here as well. So common things, minutes to hours to seconds. So our years or days, so going from that to a seconds, grams to kilograms, kilometers to meter, kilometers per hour to meters per second, which I'll demonstrate later, millimeters to meters. Those are common conversions you'll experience in physics. So here's one quick example, 1.4 minutes, and I know for every 1 minute, there are 60 seconds. And a lot of you know this already. So notice what I did. I'm going to be repetitive. The minutes have to go on the bottom so that these cancel. The 1 is attached to the minutes, which means the seconds is attached to the 60. So I'd have to do this. I don't know this number, so I am human. I will have to calculate this one. Get 84 seconds, which makes sense. Cool. Look at that. Oh, I know what I did. Huh. I'm sorry. My fault. It's not 1.4 seconds. Example 1 is 4 minutes. Okay. I'll make this right. Sorry about that. See? People make mistakes all the time. It's fine. We're human. I swear I know what I'm doing. Okay, yeah, that makes more sense. I actually think I've done this before. Either way, it's the same conversion. Ta-da! 4 days, see I didn't do it this time, 4 days in the seconds. So if you follow my work here, so I started off in days and had to go to seconds. So in 4 days, in 1 day there's 24 hours, in 1 hour there's 60 minutes, and 1 minute there's 60 seconds. People usually mess this up. People forget the 60 minutes an hour step. So just be aware that you either A, may do this yourself even with prior knowledge of me telling you, or B, that you just might forget altogether. So just be careful with that. So if you have to do a multiple conversion, you can do something like this. Something that I find very helpful is in 1 hour, there's 3,600 seconds. That's just like really, really good to have around, because now if I do it this way, 4 days times in 1 day, there's 24 hours, right? And then 1 hour, there's this many seconds. So notice I eliminate that last 2 steps. 4 times 24 times 300, 3,600 gives me the same answer, which it should. But just showing you another trick for you to use. Okay. I wish those things weren't there, but that's okay. All right, so something you'll might come across is going from kilometers per hour to meters per second. I'm going to do it down here. When you do a double conversion, you convert 1 unit at a time, while ignoring the other unit. So what do I mean by that? So what I'm going to do is I write it like this, 32, And it's saying instead of this fraction, which is actually really, I find hard to do, I write it as a horizontal fraction like this. So when I do that, let me just shut my phone off. There we go. That's not annoying, right? Okay, so I wrote the conversions up here. So first step is, of course, to look them up. And then you're going to pick which one you want to convert first. It actually doesn't matter the order. In fact, because of that, I'm going to choose to convert the hours first. So hours. 1 hour, there's that many seconds. So I would draw the line first. Then, since hour's on the bottom, hour has to go on top here because I want them to remember cancel. The hour has the 1 attached. And the 3,600 seconds goes on the bottom, which of course is what I want. So I usually circle the thing that I want and make sure that that's correct. It is, because it's on the bottom, so that's good. Cancel. I want green. Do I have green? Better green? Better green. Nope, that's not what I wanted. It's green. Better green. That's okay. All right. So now I'm going to multiply and work on my kilometer. Kilometers on the top, so it has to go. Oops, has to go on the bottom here. Oops. My pen got a little laggy. Like that. Kilometer has the 1, so the 1 goes with it. And then the meters has the 1,000. There you go. Kilometers cancel, good news. And I'm left with meters. Meters over seconds, perfect. And then you go ahead and do the multiplication. So 32 times 1, divide by 300, 3,600, times 1,000. 8.8, around 9 meters, and then I'll go back to this because it's just more compact that way. So there you have it. You could also do 32 times 1,000 divided by 300, 3,600. That also gives you the correct answer. So you'll definitely have to do this at some point. So definitely come back to this if you need a refresher as you do these types of questions. And you can see there it is. And notice in this case, I did it with the kilometers first instead. So like I said, it doesn't matter. And if you notice, I actually stopped at the 8.8, which is fine too. 8.8 would be acceptable, 8.9, 8.89. As long as it's close to the answer, I'm pretty sufficient with that. So this is like a you try kind of one. So why don't you try this example and see what you get here. So I recommend actually stopping the video and seeing if you can get the correct answer. So I'm going to pause very briefly to pretend you are pausing as well to try this one out. Okay, I'm going to assume that you paused and tried it out on your own. And I'm going to do that, which seems super awkward. It's totally awkward for me to sit there and like think about and look at nothing, right? But if I were in a physical classroom, I would actually have you do this. Being more interactive with things like this and making sure, these are great checkpoints too, to make sure you understand these concepts. So definitely take the time to do it. You have some time, I assume, right now. But I hope you do actually do them. But let's see. Going from meters per second to miles per hour. There you go. Usually it's about half. It's not exactly a half. It's 2.4, but 8.8 meters per second is about 19 miles per hour. So notice that conversion right there. Okay. That was a U. Oops, too many. Here we go. Come back here. Okay. So when it comes to graphing in general, this is, I know you've all seen graphs at some point, so I know that, so please bear with me with that. It's excuse me, but what we're going to do is with physics, this is no longer just an expression. It actually has some meaning. So when it comes to y equals mx plus b, y can be anything. In fact, one of our first lessons, y is going to be distance. And then time is going to be x. So the slope of y over x, as you can see here, the change in y over the change of x is by definition of velocity. So we can actually find the velocity of an object by looking at the slope of a graph. Very cool. B is the y-intercept when it comes down to this. So these are our initial conditions. So if I want to know where the object was, the distance, because that's what y is, at time equals 0 when it started, it tells me right here. If this were a true graph of what I was talking about, the object started at 2 meters and was moving at 1.5 meters per second. So very, very important that you understand graphing, or at least how to read a linear graph. If you need more help on this, let me know. Another important feature we'll use constantly in this course is right triangles. So we're going to use Pythagoras' theorem. So a squared plus b squared equals c squared. Who put an h here? Come on. Why would you do that? But most of you know the Pythagorean theorem. This is good for finding the side. If you have all the sides, or two of three sides of a triangle, that's really helpful to use. The trig identities are going to be very important because it turns out that things move not only just back and forth, but they move up and down. Fun fact, right? Actually, they move back and forth, up and down, and in and out technically, but we'll eliminate that total vector for you. But we do have to be able to very easily calculate the angles of a right triangle. If they're not right triangles, we'll make them right triangles because it's just way easier. But we should be able to find the angle not only of this angle right here, but up here as well. So being able to read that. But looking at this angle, the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and opposite over adjacent is tangent. So I usually look at it like, is it next to it? It's a cosine. If it's across it, it's a sine. If I just have these two, it's a tangent. Those are my shortcuts. And I know I did that fast, so don't worry. Good news is I'll do a ton of those. So you'll have more practice. Yes, calculator technique. So I know all of you are probably like, I know how to use my calculator, which is true. You do. But through my years of experience, these are where people make mistakes. So I just want to go over them. The first thing is people make a lot of mistakes entering large numbers or small numbers into your calculator. That is because your calculator, if you don't enter it in correctly, follows the order of operations, or please excuse my dear Aunt Sally. I ignore that piece. But the problem with that is if you don't enter it right, it comes out wrong. So you can actually have the right value, but the wrong answer, and I don't want you to do that. Now, if you do this without any problems, you've never made a mistake, or they're very far and few, then you could ignore my method and obviously do what works for you. If not, you could try my method. So I actually have a calculator right here to show you that. So say you want to enter in that value you saw on the screen, right? 6.67 to the negative 11th. I highly recommend you do it like this, 6.67. Then you press the second button. Then you can press this button. There's a double E right here, but I have to press the second to get it. Obviously, if I don't press the second, I get the comma, which I don't want, delete. Now, this means times 10. And notice I didn't put a multiplication symbol here either. That's really nice. So you just literally put it here. And then you're going to use the negative, not this sign, but the negative sign, 11. Now, if I press enter, it gives back the same value, but that's nice because then I could do, 6.67, you get a negative 11th, times, 9, 1 mass, times my second mass, 25, equals boom. And that will come out correctly like that. So I highly recommend that. Mistakes that people do. Don't do this, 6, 7 times e to the negative 11th. Why? Just don't. I guess it didn't do anything there. That's all right. It seems to be okay. Let me see. Hold on. I'm going to check it now. Watch. Live check because I don't know what's going to happen here. Oops. See? Too good. I want to get rid of all this. I want to put it as times. Sorry. Delete. Delete. Delete times 6 point, oops, I'm not thinking now. Let me try this again. Sorry, bear with me. Promise, I'm okay, and I know what I'm doing. Negative 11. It's the same numbers, times 9, times 25. Let's see what happens here. Okay, I get the same answer. All right, I guess you can ignore that. I thought people had problems with that, but it seems to work. Fun fact. What you shouldn't do, I know doesn't work, and I've seen people do, is use the little e button. Little e. Watch this. Not the right answer, okay? So this does not match that. So notice that people have done this before. And then some people have done this before, 6.67 times 10 caret negative 11. Now most, and this does work. I just say caution because when you do multiple values, so let me do that again, 6.67 times 10 caret negative 11 times 9 times 25. Okay, that looks pretty good. But I would err on the side of caution when it comes to this because sometimes it doesn't come out if you have more operations or if you divide or if you add. So just be very careful with this. So those are just some ideas for you. So yeah, okay, let's go back here. This is a fun one. Being able to do something like this. So this is a gravitational force equation, and I'll tell you that 80% of people get this question wrong, and maybe more. Not because they can't do this, because you're just plugging in your values. The problem is the way you enter it into your calculator. So I'm just going to demonstrate the way I do it. Once again, if you got this down, you can ignore me. But it's just, like I said, it's just what I see when people do this. So I'm going to do 6.67 e to negative 11th times, I think it's the mass of the Earth, which is 5.7 to the 24. Actually, I'm pretty sure that's not, I think it's the 23rd, but that's okay. We're just going to go with our example. And then the mass of the moon, which is, let's see, 735.22. Now, a lot of people would do the division and then do the bottom squared. I usually do like this. I do the whole top row first, get an answer, go to. Let's see, what did I do? What did I do? Looks fine to me. Oh, I think oh, it's that. I did that before too. Why didn't you stop me? Negative, sorry. Because I'm typing it. I know what I did wrong. Can I go back to this line? No. Alright, never mind. Okay. Yes. One quid. 6.67. I know, one quid. Technology. Just tried to do something different here. One. Okay. Second E. Negative 11. That's what I did wrong. Sorry, folks. Bear with me as you watch me struggle through a calculation. That should be pretty straightforward. Oh my goodness. Da-da-da-da. There we go. Very good. The physics teacher can use the calculator. Okay, so now that I have this, I usually will actually take the answer that by doing the division. And then the bottom is the distance, 3.84 to the 8th. But this thing is squared too, so I'll use the square button in this case. Press enter. And woohoo! We got the right answer. That's important, of course. So a couple things. Some people forget this exponent, so be careful. Usually with gravitation, they're going to be either very large or small numbers. So just be aware of this. Now, of course, there are cases that don't have large or small numbers, but most of them will. And then, of course, the 1.98 roughly is our answer here. I recommend you try this calculation as a test to see how well you can do this. If you do it the first time, just fine. Awesome. You don't need to spend time on this. But you will definitely need to do this. Number one question I get on homework questions, especially these types, is, I can't get the answer, and it's usually they forget to square the bottom, or you forgot to multiply, or you added instead of multiplied. I mean, most of the time you understand what's going on. It has nothing to do with, not understanding, but just how to enter it into your calculator. My last thing to show you is if you are interested, you can store things in your calculator like constants so you don't have to keep using them. A very cool little trick. Let me show you. Let's clear everything for now. Say I want to store that number. This is the gravitational constant for gravitational force. So first I'm going to write the whole number in. And then I'm going to press store, alpha, and then I'll find the letter G. So I'm going to store this as G. And I press enter. And there you go. So now anytime I press alpha G, and I press enter, it's my number. I could do 2 times alpha G. And notice that it in fact is double that. Great. Just to show you, if I did 2 times alpha, not G, I get 0. So that's one way you could check it to make sure that it works, that it's not, a 0 value. So very cool little thing. In fact, I think I wrote it backwards. I think it's, so let me fix this. So it's enter this value first, and press store, and then alpha G. So let me just fix this. You'll get the updated version. There you go. There you go. So let's do one of those. Very good. We fixed that up. Very, very helpful, especially for something like gravitational constant. Remember what I just did? It's just so much easier instead just to do alpha G. It's less likely you'll make a mistake. 5.97 e to the 24, you get the idea. I'm not going to go through the whole calculation, but it's just one less thing you have to worry about entering into your calculator, which is super helpful, right? Okay, here's a bunch of other things in terms of, videos for extra help. If you want an additional video, or if you're looking online for a video that's really helpful that's applicable to this class, I could find one for you. I know what happens is you get lost in a whole ton of different videos online, so if you want me to cipher out a few, or if you recommend a few that are helpful for you to share with others, let me know. I'll put this on the list. But yeah, this is just meant to help you out. I hope you found some information here helpful, or at least some quick little things to be cognizant of and what to worry about when you're doing this course. And if you have any more questions, of course, let me know. I'm going to reinforce all these concepts in the context of the class, so you don't need to know exactly how to convert like 100% if you're feeling a little uncomfortable. We actually do so many that you'll get comfortable doing it too, so just know that as well. All right, so this ends my lecture series on the Intro to Physics Measurement.